In this PowerPoint, today we are going to cover Introduction to Logic in C#. So let's begin with talking about binaries. Computers are constantly checking the state of something. Things like, is this program running or not? Does this variable exist or not? Or is this value equal to that value? So these yes or no questions demonstrate that a number of binaries, and binaries are a relationship between two entities, exist. Computer programs essentially function off these binaries. And binaries are things like true or false, yes or no, ones and zeros, on and off. Okay, so distinguishing between binaries is the foundation of Boolean logic. Boolean logic is based on the idea that all values are either true or false. Logic is important to computer science because it's an early attempt at translating the human capacity to reason to computers. So if a computer can use logic to reason about certain situations, it can then use that rationale to make decisions. So in this unit, we're going to learn how Boolean logic works in C#, and we're going to learn how to implement Boolean data types and expressions in your own programs. Programmers first were able to illustrate the idea of binary logic by turning on and off electric circuits, where on equaled true and off equaled false. So on is true and off is equals to false. So in fact, the relationship between electricity and logic is the basis really for digitization, how we store information with electrical circuits. In C#, we can represent Boolean values using the bool data type. Booleans, unlike numbers or strings, only have two values, true and false. So to define a variable as Boolean, you define the data type as bool, and then write the variable name and set it equal to the value, either true or false. So here we have the data type, the variable name, and then the value, which should be true or false. Okay, so when writing a program, we often need to check if a value is correct, or also we can compare it to different values. So a comparison operator allows us to compare values and then evaluate the relationship. So rather than evaluating to an integer, they evaluate to either true or false values. So the expressions that evaluate to Boolean values are known as Boolean expressions. So here we have the comparison operators. We have the equals, which is two equal signs. This returns true if the value to the left is equal to the value to the right. Okay. We also have the inequality operator, which is an exclamation mark, and then the equal sign. So exclamation mark first. This returns true, okay, if the two values are not equal. So if the two values are not equal, then it will return true. Okay, if this is not that, then it's true. Then we have the less than. Okay, so this returns true if the value on the left, is less than the value to the right. Then we also have the greater than, and this returns true if the value on the left is more than the value on the right. We also have less than and equals to, which returns true if the value on the left is less than or equals to the value on the right. Okay, then we also have the more than and equals to, and this returns true if the value on the left is more than or equal to the value on the right. So let's take a look at this example. So Boolean answer equals 3 less than 75. So the question is 3 less than 75? If this is true, then it will print true. Okay, and you can go try this out. Open up Visual Studio and just type this in and try that out. We can also compare variables. Okay, so the answer is a variable name. This is the data type here. So all this is going to give me a true or false. Okay, so is this value on the left equals this value on the right? Are they the same thing? Is true equals the same as false? So the answer is, of course, false. Okay, so here we use equals comparison to comparison operator to see the Boolean value is true is equal to false. Okay, again, you can go pause the video and go type this out quickly in Visual Studio and see what happens. Next, let's talk about logical operators. We can use these operators that use Boolean values as inputs and outputs. Logical operators, also known as Boolean operators, can be used to create Boolean expressions. So there's AND, which is two ampersands, which means both expressions are evaluated and return true only if both expressions evaluate to be true. Otherwise, it will return false. If even one of those expressions are false, it will still be false. OR means both expressions are evaluated and return true if at least one of the expressions evaluates to be true. So even if one of them is false, but one of them is true, it will still be true. Okay, unless both of them are false, then it will return false. And then there's not, which is an exclamation mark. So as an expression, no matter its logical value, it's going to evaluate the opposite. Okay, if something is not this, then it is true. All right, so we have a truth table here, which makes it a lot easier to see what I was just talking about. So if A and B are true, then A and B is A and B is true. If A is true and B is false, it's still false. If A is false and B is true, still false. And if A is false and B is false, of course, it's false. Okay? So what it means is that for AND, you need both A and B to be true for it to be true. Or it only takes one of them to be true. So if both are true, it's true. If only A is true, the result is true. If only B is true, the result is still true. So it takes both of them to be false for it to be false. Now, in not, if A is true, then it's false. Okay, if A is false, then the result is true. So if it's not A, then it's true. All right, so an example using AND. Okay, so here we go. If this is the data type here, boo, and example is my variable name. Okay, so the two conditions are 4 is more than 1 and 2 is less than 7. So is 4 more than 1? Yes. And is 2 less than 7? Yes. So both is true and true. So the whole thing is true because of n. So both comparisons evaluate to be true. So the overall expression evaluates to be true. And the OR example is if A is more than 6 or 3 is more than 6. So obviously 3 is not more than 6. The second expression is false. But the first expression is still true, so it evaluates to be true. Okay, so only one comparison evaluates to be true, the other evaluates to be false, so the expression still evaluates to be true. In the not example, it can take a little while for you to wrap your head around it, but if this expression is not true, then it will be true. But if this expression is true, then it will evaluate to be false, which is what happens in this situation. So it can get complicated. Handling two Boolean values is simple, but longer expressions can be very complex. So it's important that you're familiar with these fundamentals. I know I just went over this really basic things, but it's important to review this and really have it, have it memorized and have it well understood before we can move on to more complex things going ahead. So in complex expressions, often Boolean expressions can become extremely complex. So rather than determining if one relationship is true or false, we usually evaluate several expressions by connecting them with logical operators and then determining the validity of the overall expression. So we'll be breaking things down into smaller chunks, evaluating that, and then determining the overall expression in general. All right, so that's it for this basic introduction to logic. And moving on, we will explore each area in more detail.